Morning, everybody. Hopefully you enjoyed the keynote by Andy Jassy this morning. One of the things I'll be talking about today is an update that he announced to all of you that attended that session. A couple of keynotes, a couple of key things for the talk today. This is the media ingest and storage session. It's a 200 level, so there will be some acronyms. I apologize if I don't explain them. So we expect a certain level of detail already known by the audience. But in terms of what we're going to talk about today, we're going to talk about S3, and I'm going to talk about the other options that you have aside from S3 and different flavors of storage that we see in the media sector. We're going to talk about Glacier. We're going to talk about the integration that was recently announced between S3 and Glacier. Then we're going to talk about, once we understand the storage options that you have, we're going to talk about how to get the data into AWS. Ingest is obviously job number one in the media sector for many customers. And speaking of customers, I think the best part of the presentation will be our customer Imgur, who will be coming up towards the end to talk about how they migrated over to AWS and how they run their operation in the cloud. So Amazon S3. Amazon S3 is a simple storage service, and it's extremely durable. 11 nines of durability for S3 standard. What that means is we can withstand up to 2 full data center losses and still maintain your data. So this is the most durable storage subsystem on the planet. It's great for media folks as well, because I've spent much time working with media companies as well as finance companies over the years. And you would think that finance folks would be more maniacal about their data, but it just isn't true. The media sector is, because the finance folks are storing their data and saving their data because regulatory bodies are requiring them to. Whereas in the media sector, you want to hold on to these assets, right? You never know when an asset can be remonetized. And we'll talk a little bit about how we can do that better using the cloud. Now, in terms of size, we're not only durable, but we're large, right? We have over 1 trillion objects, unique customer objects in S3. And I'm going to describe a little bit about how we do the durability, but I did want to point out that these are unique objects. So we've grown quite a lot in the past 6.5, going on 7 years in February. We also handle a lot of transactions. So on average, per second, about 750,000 transactions are managed by S3 globally. So we handle a lot of transactions, a lot of business. Now, with S3 standard, we do have 11 nines of durability, but you do have a trade-off. So over the years, our customers said, you know, I like the durability of S3 and I like the price, but I don't need that kind of durability for some of my business. So if you think about some folks that might be in the business of delivering MP3 files, they might not need 11 nines of durability, because if you did lose an object or file, it's very easy to replace that. So customers wanted a trade-off. So we announced reduced redundancy storage. Still runs in the same storage subsystem as S3, but it does have reduced redundancy, offering 4 nines of durability. Now, in terms of how we maintain this durability, we have this concept of regions. We now have 9 regions around the globe. And these regions are comprised of multiple availability zones. And for lack of a better term, availability zone is our fancy term for data centers. So these are geographically unique data centers, geographically dispersed data centers. So when your object is moved into S3, we're doing some things for you. So on average, when you're doing business with AWS as a new customer or a new project, you're going to make some choices. Right? Choice number 1, choose a region. Choice number 2, pick an availability zone. And then choice number 3, start building your assets in that availability zone, provisioning your EC2, provisioning your EBS, et cetera. And you might even choose, actually, an option 4 is to load balance between availability zones to create a highly available architecture. With S3, you don't need to make these choices. We make them for you. So every object that you upload into your availability zone, for lack of a better way to describe it, multiple objects are going to be maintained within that availability zone and across all availability zones. So that's how we maintain the durability. Now, in the case of RRS, the only change in the infrastructure is that in the architecture is that we're keeping fewer copies across fewer AZs, which is why we have the 4 nines of durability. So you need to make your choices there. Now, the trade-off between S3 and RRS is about 20% in terms of lower cost for RRS. Now, we get asked by a lot of customers, can I replicate between regions? And there are many reasons to do this. Our customers aren't doing it for durability, obviously, because S3 is extremely durable. But we do have use cases in some sectors where, for compliance reasons, you need to keep a copy of your data 250 miles away. So if you're running in AWS in region 1, you might want to push the data into another region. In the media sector, we see customers that might want to keep their data within regions and then deliver through CloudFront. So we have customers that have core assets in Japan as well as core assets in US East, and then they use CloudFront, especially in the gaming business where performance is key and you want to keep those assets very close to the customer. So in doing that, you can turn to a customer called Attunity Cloudbeam. So with Attunity, you have a couple things you can do here. One, you have their software appliance, and this is offered as a service model. They're actually in the trade show booth, I think in like 501 or something like that, if you want to check these guys out. But you can move not only your active data, but you can also migrate and sync your VM images, et cetera. And then you would configure your S3 bucket to automatically beam that data to another region. And this is done in the background for you. You can either do it manually, so just click and migrate the data over, or you can set up a schedule, an automatic schedule, so everything that goes in that bucket immediately goes into another region. So they're a great solution. It's great for DR, it's great for backup, but more importantly, it's really, really good for media distribution. Now, Attunity Cloudbeam is important to know. They are publicly traded on the NASDAQ. They've been around for about 10 years, and this is a SaaS model. It is offered via Marketplace. So if you had a one-time event, you wanted to move your data from one region to another, perhaps we open up a new region, and you've been running in Singapore, and we just opened up Australia, you might want to configure Attunity Cloudbeam, move your data over to Australia, and then shut down your assets in Singapore. So a lot of different use cases for this. Also, if you do stop by their booth, Attunity is one of the first partners to offer integration with Glacier. So please stop by their booth and say hello to Itamar, who's sitting right here in front of me. I just noticed you guys there. So great partner. So speaking of Amazon Glacier, we did just launch this low-cost archiving service. And this was in direct response to our customers who had been saying over the years, again, we talked about trade-offs earlier. They liked the trade-off between S3 and RRS, lower price, lower durability. But for some use cases, it was not the right trade-off for the customer. What they were looking for was very low price, compellingly low price, with perhaps longer time to retrieve. And so we actually launched Glacier earlier this year. Very disruptive technology in the marketplace. And it's a penny per gig per month. Right? So to put that in perspective, $120 per terabyte year. So very, very disruptive. Now, we did launch this as a standalone service. Trouble with my finger. And it's important to note that it does have the same durability as S3, so no trade-off on durability. So you still have the same architecture in terms of replicating across all availability zones in the region that you choose. So it's highly durable. This is meant to be a very long-term archive, right? Not meant to be an active repository. So you definitely want to think about things like tape elimination. We see many of our customers saying, OK, I can get off tape. And when you think about the 50-year archive, the 100-year archive, the infinite archive that most of us in the media sector are looking for, Glacier gets you out of the business of maintaining what we call tape museums, where you have to have all this legacy tape infrastructure sitting around for years. And it eliminates the need for every 5 to 8 to 10 years to doing a full tech refresh, doing a full restore of all your data, backing it up on the new media, just so you maintain that asset. We also see use cases where you might have end of life on a certain format, and you might want to reformat all your assets. Glacier, the unique thing about this archive is that for the first time, your long-term archive is sitting next to the world's largest supercomputer. So if you take an example like Netflix, who we talk about quite a lot, but they have such a dynamic use case, it's hard not to talk about them. But the PS3 was coming out. They only had a couple of days, and they had 18,000 titles they wanted to make available on the PS3. So something with assets on-prem, you have limited assets, so you really couldn't scale out and handle that workload just for a couple of days and have it go away. But on AWS, you're able to scale up to thousands of servers, and within 2 days, transcode all their assets into the new format, make it available to customers across their CDNs, and take advantage of it and monetize those assets. Now, another thing to point out with Glacier, I did mention that the trade-off is lower price, right? Same durability, but retrieval time takes longer. So we talked to many, many customers about the requirements on retrieval. We heard lots of different requirements as well. We heard everything from hours, like you see here, to days or even weeks in some cases, because customers were used to retrieving a set of tape assets from an offsite archive that could take 4 days to retrieve. Then they have to mount those tapes and retrieve their data, assuming they're lucky enough to still be intact on those tapes, which sometimes they are not, and assuming they had the infrastructure to restore those tapes. So oftentimes that meant some clicking around on eBay to find the tape library that you need to restore those assets. With Glacier, we launched a 3 to 5 hour customer experience for retrieval. And what would happen in that 3 to 5 hours, see if I have a slide on this. I'll talk about S3 Glacier integration. What happened at 3 to 5 hour window is you would receive a job ID, and about 3 to 5 hours later, you can use SNS, you could use messaging to alert you when that job is ready. Then you would have a link available for download that would be available for 24 hours. Now, retrieval costs, you need to keep that in mind as well. You can retrieve up to 5% of your archive out of Glacier for free. Once you go over 5% of the archive, there is a retrieval fee. So you want to calculate that and think about how much you're retrieving. However, you can control your own costs. Because we saw requirements of not only hours, but days or even weeks, we decided to put control in the developer's hand, say you can stretch that retrieval time up over hours or days and greatly reduce your retrieval costs. So S3 Glacier integration. So Glacier can be a standalone archive. And you may want that to be a standalone archive for MPAA obligations or other reasons. But many customers also want seamless integration between S3 and Glacier. So you can imagine a process by which you have objects in your S3 bucket. And then after, let's say, this is just an example, after 30 days, those objects can automatically move over to Glacier. And then after 365 days in this particular example, you can automatically expire those objects. I'll show you what that would look like. So you can have user-defined names, real-time listing, all the metadata and property is maintained by S3. So you still have your tag in S3. And it's accessible only through the S3 interface. So what we're creating is basically an HSM model in the cloud. So again, you can push, let's say you push your current season's episodes into S3 where they sit for 6 months, a year, the policy is defined by you. Then it goes into Glacier, and that could have a 0 expiration policy where it will live in Glacier for perpetuity. Now in terms of restore, when we restore an object, we're not pulling the object out of Glacier and into S3. We're going to make a copy of that object. So we'll always be in an 11.9s of durability infrastructure. But when we do the copy, we're going to put that copy in RRS, which has the same performance as S3. Then from there, you can do whatever it is you need to do at the time. If you're going to transcode, if you're going to redistribute, you're going to stamp it on a DVR or DVD and send it off to Walmart to monetize. But this is definitely transforming what we're seeing when you see these tiers. So you really want to think about, when you're using AWS, which tiers do you need to use? Obviously, on the EC2 side, there's EBS on the compute side. We'll talk about that at a storage session at 1 o'clock today. But we really are seeing that HSM model. And for the financial services sector and the media sector, we talked a little bit about this, right? In the old days of doing things, the traditional approach was you have different tiers of storage. For you, it might be online, then nearline, and then on maybe a disk backup, and then eventually offsite to tape. And that retrieval coming back is what is time consuming, and there's risk that you have data loss from tape. So in this model with HSM with AWS, again, policy-based, so set and forget. Data move seamlessly over into Glacier, cost optimized, bring it back whenever you need to. We also cover FDA regulations as well, so in regulated industries, and I bring this up because we have a lot of medical imaging customers, and their workflow is exactly like your traditional media workflows, exactly the same thing. Some of the acronyms change, but they have the exact same needs. So in that sector, they have to do full OS images that they have to save for a number of years, and that could be a version of Microsoft 2003, et cetera. And those images then have to be saved, in some cases forever, or the life of the patient. So great use case if you're in the medical imaging sector. And a little bit about data ingest. We recently, I'd say earlier this year, announced the AWS Storage Gateway. Storage Gateway is a software appliance, and that is downloaded into your data center, so it's an on-prem solution, and it's configured and spun up on an instance of VMware. There are 2 versions of this gateway. There's backup and DR version, and then there's what's called cached volumes. Now, cached volumes would be a way to thin provision your assets on-prem. So what you can do is you can tell the gateway to say, okay, for certain assets, I want to keep them on-prem because they're frequently accessed for, let's say, 3 days. Then I want to snapshot them all automatically to S3 where they live for 30 days. Now, the user experience, the user doesn't know that the data just moved over to S3. It still looks like a single directory. Everything's right there on-prem. Right? So we're tricking the user a little bit. And if the user needed something, as long as your use case, user can withstand a few hundred milliseconds, they'll pull that file back down that they might need in the first 30 days. And then, of course, you still have the option to age off into Glacier. So now, not only are we HSMing your data to cost optimize in S3, we're thin provisioning the assets that you need on-prem, which means you can either on your next buy cycle reduce the footprint because frequently accessed files are typically, we find, about 15 to 20% of your assets. So you can shrink your next buy, or if you're getting to capacity on your current assets on your NAS or your SAN, you can actually extend the life of those assets and use those budget dollars somewhere else other than new on-prem storage. The other version of the gateway is purely for backup and DR. So if that's your use case, for a DR scenario, you want to get your data in AWS, what you do is download the DR backup version of the gateway. What this is going to do is keep one copy of the data locally, so everything will remain local, all assets going through the gateway. And then we'll do a snapshot into S3. And that'll be done in the form of what's called an EBS snapshot. And the reason that's important is that there are a lot of gateways out there that support AWS natively today. Many of them are doing proprietary things like encryption, compression, deduplication. Once you've done that and you put the data in S3, that data would have to pass back through that gateway, that third-party gateway, in order to be used in the rest of AWS. So if you wanted to transcode those assets, you'd either need a second virtual version, or AMI version, of that gateway running in EC2 that you also own and pass the objects through there to normalize the files and then go ahead and use them in EC2. When you're using the gateway for backup in DR, you don't need to do that. Right? You move the data into S3. It's in the form of an EBS snapshot. So if you need to do something in EC2 with the data like that, you can do that. Now, the other thing that we support is parallel uploads. Now, if you're not familiar with this allows more flexible uploads into S3. So you can upload in a single object as a set of parts. Right? So we're going to split that object up and create parallel uploads. You can pause and resume. This is going to greatly speed up how quickly you can ingest into the cloud. However, we get asked from a lot of our customers, especially on the initial ingest, can I do it faster? And if you've got workloads that you need to move consistently into AWS, or perhaps you're running in a hybrid environment where you're storing and transcoding some assets in AWS, and you're storing and transcoding some assets and delivering some assets on-prem, you can use AWS Direct Connect. So Direct Connect is simply bypassing the internet. You provision a point-to-point connection from a port in your data center to a port in one of our cross-connect facilities, and then you'd have a gig-E or a 10 gig-E direct connection into AWS. So greatly speed up your ingest or greatly improve your predictability of your performance, so you're not going over the internet where you might not have predictable performance, but on a Direct Connect, you will. So even though we have Direct Connect, and we have many other options like import-export, you can ship us disks, and we will import them for you. So if you have a one-time move and you want to do an import and not go over the wire, you can look on our website for AWS import-export, ship us those disks, and we'll go ahead and upload them locally into your bucket. The other thing we can do, if you use a third party for DR services, some of our customers use export to export. We'll export to a disk for them, and we'll ship that to the third party. We have many of our, in the GIS sector, many GIS companies tend to do business with each other, and if they're not all running in AWS, we can move their assets into an export and then ship that job out for monetization out in the field. So that's another way to turbocharge the ingest. But even more importantly, customers who have Direct Connect or don't have Direct Connect who want to turbocharge, they can use Aspira, which is an end-to-end ingest, transcode, and distribute engine available on AWS. This is a great solution, and here we have an example of the UFC, Ultimate Fighting Championships. In legacy processes, you transcode and distribute. Video is captured and then transferred using TCP. And we know that this can be slow given the limitations of TCP. Then the video needs to be transcoded into, let's say, 14 different formats. And if you're on-prem, you might have to wait for the first set of formats to be finished and then transcode the next set of formats, et cetera. It's time-consuming, right? But you want a format for your tablet, for your iPhone, Android, for the PC, et cetera. So what you can do using Aspira, in this example here, is obviously you get your video broadcast and capture. You do the high-speed upload through their proprietary technology called FASP into S3. Then from there, you can scale out and in parallel transcode all your assets into all the different formats you want to transcode to. In this example, then they're then pulled back down to S3 over the wire, again using FASP, and then this model distributed for streaming to cell phones. The other option in this environment, once the assets are transcoded in S3, you can also use AWS CloudFront, which is our CDN, and you can distribute through the CDN. Or you can distribute direct from S3 to your customer. A little bit about total cost of ownership. When looking at AWS, many of our customers are coming from on-prem environments and then they're looking at AWS. And it's sometimes difficult to do a proper side-by-side comparison of what you were doing yesterday with on-prem versus what my costs are in AWS. There are common mistakes that are made. On the EC2 side, for example, many folks that are buying servers will take a look at the cost for a server, right? Whatever that is, $30,000. And then they'll say, okay, there are X number of server hours in a year, over 3 years, divided by the cost of the server, there's my hour cost for my server. Then they look at EC2, and they say, wow, EC2 looks a little bit more expensive in that environment. But what we find is our workloads aren't consistent. You're not using 100% of your server hours in a given year. Your loads are spiky. So you really need to think about the cost savings when you compare those two. In the media sector, and Alan and I had this discussion about a year ago, when you're comparing on-prem to AWS, a couple of things to think about. And one is not to compare the raw cost of storage. So if you're going to buy a petabyte of some type of NAS or SAN, raw cost of storage, you don't compare that to S3. Right? And the reason being is, one, S3 is fully burdened, right? Space, power, cooling, network. Also, it's fully redundant. So we know when it comes to storage, we don't do anything once. We buy 2 of everything, and we typically replicate to at least one other geographic data center, right? If you want a highly available infrastructure, and if a single point of failure is not an option for you in this business, in media business, it's typically not an option. So keep in mind that that's fully replicated. Also, when I say fully burdened, it's also fully configured. So if you buy 100 terabytes of on-prem SAN, first thing you're going to do is configure it. And when you configure it with, let's say, RAID protection, you're going to lose about 20% overhead. So now you only have about 80 terabytes usable. And then when you think about how we manage our data centers, you're not going to use 80 terabytes of that data. When you get to about 65 or 75% capacity, you're going to pull the trigger and buy new assets. So you're spending CapEx before you actually need to. And you don't have to do that with S3. With S3, obviously, it's fully managed, but it's also 100% utilized. And you don't find that in the storage industry at all. So you keep those things in mind. And obviously, the scale, too. We scale infinitely. We had one customer who predicted 2 petabytes over 24 months in S3. When you looked at their business models, we were working with them to migrate over to AWS. They actually hit 5 petabytes in 9 months. Right? So wildly successful business. Their board was extremely happy. But you can imagine how much different that story would be if that customer chose on-prem assets. Right? They would have collapsed under the success of their own business. And they would have had a denial of service go out to their customers. Customers move on. Right? We have a lot of options out there, right? And businesses move extremely fast. You can't afford not to be able to scale, so S3 does scale infinitely. The other thing to think about is your databases and managing your databases, right? When Alan and I first talked, and I think you'll talk a little bit about this as well, we have customers that go, okay, so here's the cost to manage my own database, using my own database licenses and my own servers. And then they compare to RDS. And they'll say, well, RDS is more expensive. But you got to keep in mind that the proper comparison there, by the way, would be move your licenses over into EC2 and use EBS and manage the database yourself, manage the patches, et cetera, yourself. Using RDS is a fully managed service, so keep that in mind. Right? Initially, I don't think some customers start with managing their own database, and when they realize they can get their weekends and their nights back using RDS, they migrate over. So with that, I want to bring up the founder of Imgur, Alan Schaff, to actually talk a little bit about how he built his business. Thanks, Alan.
Hey guys, I'm Alan Schaff, founder of Imgur. So if you're not familiar with Imgur, Imgur in its simplest form is an image sharing website where anyone can share as many images as they want to whoever they want, as many times as they want. And every day we see about 2 million images uploaded, which ends up being about 23 images per second. And an interesting thing about Imgur is that these images can be hot linked or embedded on other sites. So you're not just viewing them on Imgur, you're viewing them literally out on the web. And so let's take some advice from Urban Dictionary. Imgur is the greatest image site, full of all the wonders and magic of the interwebs. Be forewarned, time has been known to quicken in this realm. I spent half a day on Imgur, and it was the greatest 6 hours of my life. Urban Dictionary also said, and I quote, "Imgur is a goddamn staple of the internet." So I really like that quote. So the images that end up on Imgur are spread throughout the entire internet. And that's kind of the point of Imgur, is to upload your image to Imgur just really quickly and then share it out to your friends or to Facebook or to Reddit. And so the average image that you can find publicly on our site is shared more than 300,000 times. And because of the decisions that we've made that allow anyone to upload and to share it out to as many people as possible, that's really spawned some really interesting scaling problems that we've come across. And that's kind of what we're here to talk to you about today. So Imgur started as just a side project while I was an undergrad in Ohio University. It was never really, or I didn't really start it as a business. I just wanted to create something cool and put it out on the internet. And so I've always been an avid Redditor. And so I released my creation out on Reddit. And it just kind of blew up, and the Reddit community loved it. And then it organically grew into a business. And then I had to figure out how to scale. And so I was the only developer for about 3 years. But now we are a team of 7. And that means each developer handles more than 600 million page views every month. So we get a lot of traffic, and we have a lot of data. Every month, there's 2.9 billion page views, 38 billion image views, 54 million unique visitors, almost 5 petabytes of bandwidth or data transferred every month, 62 million images uploaded, and we're the 46th biggest site in the United States, and we have about 600 million objects stored in S3. We're also growing at a rate of 15% every month. And before we moved into the Amazon cloud, we were on dedicated servers. And that yellow dot on the slide indicates when we switched from dedicated servers over to Amazon. And in a year, we more than doubled our page views. And Amazon was able to support that. So here's a brief look of what our dedicated server infrastructure was like. We had 2 proxy servers, which also acted as database servers. A little unconventional, but it worked pretty well. And then those load balanced a number of www servers, which were all connected to a big NFS cluster that was managed by our host at the time. And that worked pretty well for about 2 years. But eventually, where do you go from there? We can continue to just add more servers. And we were actually getting problems with hardware failures, and our host at the time didn't do a very good job of managing that NFS cluster, so that ended up being a single point of failure for us. So projecting out how many servers we're going to need 6 months from now or a year from now was just getting really difficult. And the thing about managing your own servers is that you have to tweak and set up every little thing yourself. And there's one guy, myself, doing all of this. So, more importantly, how can we make my life easier and, scale the site at the same time? So we ended up going to the cloud, and we chose Amazon for a couple key reasons. One was that auto-scaling is awesome. And if you're not using auto-scaling and you're on EC2, then you better have a really good reason why you're not. The automated DB backups are awesome, and the security features are awesome. So, combine all those awesome features, and it was really kind of an easy choice to move to, Amazon as the cloud provider. And since everything is managed, that kind of takes some weight off of your shoulders and actually gives you a little bit of time back, because now you don't have to worry about, all the fine details. Amazon is actually handling those for you. And plus, they have pretty much everything you could need. They have caches, servers, databases. You can do backups of all your stuff. They have security features. So they have everything you could really need, at least everything that we needed to run our website at scale. The biggest problem with actually getting into the cloud was just learning about it. And you're literally reconfiguring your entire stack when you go from dedicated servers over to the cloud. And so it's just really time consuming, and of course there's possible downtime when you're migrating your production over. So that was kind of the hardest part, was just learning everything. So where do you start? For us, we kind of had to figure out what Amazon can actually provide us and what each one of those individual services gives us. So once we figured that out, we stuck everything into the pricing calculator, figure out how much it's going to actually cost us, and that was acceptable. So then we read the docs, set up a test environment, and Amazon actually encourages you to call them if you have any questions. You don't need the Amazon support or anything to just call in and ask how you can set something up. So that was really helpful. And then, of course, just install their SDK and start doing it. But more specifically, where do you start with S3? At the time, we had about 150 million objects to move over. And that doesn't even account all the thumbnails for all the images and everything. So that's literally just 150 million raw images that we had on this NFS cluster that we had to move over. And so what we did was we duplicated our writes. So everything that happened on the native file system also happened on S3. And then that allowed us to upload all of our data in parallel to the cloud. And we had 12 processes running, each uploading a different subset of images. It took about 2 weeks to actually get everything into S3. But in the end, since everything was kind of duplicated from one to the other, we just flipped the switch, and now we're on S3. And there's no need to store more than one copy, because S3 is not going to lose your data. You just heard about how durable it was. So the only thing you kind of have to worry about is a developer accidentally deleting everything you have. And even if you turn on versioning, that's less of a risk, because now even if a developer does accidentally delete your stuff, you can go back to the previous version. And it's a very similar process for RDS. So I mentioned that if you're not using autoscaling, then you should have a really good reason why not. But it's not without its own challenges, too. For one, there's no web interface. And it's easily one of the most useful features for us, so I don't know why there's no web interface. So hopefully they're working on that. But for now, you have to do everything from command line. The terminology is a little confusing, too, and it's kind of hard to understand or hard to verify that it's working as intended. But in the end, it's pretty amazing. And so we are on MySQL for all our database needs. So when we were evaluating, when we move over to the cloud, should we do RDS or should we manage our own stuff on EC2? So it turned out that you can get better performance on EC2 if you do it yourself. And the reason why that is because you're allowed to tweak every little fine detail about it and really get the maximum performance. And now you can RAID together 6 provisioned IOPS drives or use one of the newer high I/O instances and really get better performance. But the question that you need to answer is is it worth it for you to do that? It's going to be a lot harder. It's going to take a lot more time. You might have to have somebody dedicated to actually do that. So we chose RDS, and the reason why that is because it's fully managed, so you don't have to do all the fine details yourself. It gets pretty good. It gets very good performance out of the box, but again, it's not as good as you could get with EC2. So I guess the moral of the story is, if you enjoy tuning every little bit for performance, then you should go with EC2, because if performance is your thing, and you can get better performance with EC2. But in the end, if you just want a database up there and you want a high availability solution out of the box, then go with RDS. But of course, RDS is not without its own challenges, too. The biggest one for us is there's no access to the underlying file system. So when something breaks, like let's say one of your tables gets corrupted, you're pretty much in the dark about it. You don't have any logs to actually go back and see what table that actually is or why it crashed. It just, OK, it failed over onto the other instance if you're using a multi-availability zone RDS instance. If it just fails over, you don't know why. Maybe there's an outage for RDS. Maybe not. Maybe one of your tables is corrupted and MySQL crashed. So that was kind of a problem for us. And of course, migrating over requires a complete dump and import of all your data. And so our database at the time was around 150 gigs. And so doing a complete dump and import of that just took forever. So that was also a challenge for us. But we were able to do it live, actually. We didn't even take the site down, so that is possible. But it was with lots of headaches, actually. And so you saw what we did during our dedicated servers. So now this is our current infrastructure on Amazon. So EC2 has allowed us to create clusters of just about every different part of the site. And so we've got our proxy cluster and our upload cluster, API, www, just an image cluster if you just are requesting an image, Redis and search. And then they're pretty much all hooked up into Elasticache, which sits before RDS. And in case there's something wrong with RDS, like maybe yours max connections or something, then it'll go over to the read slave. And so this has worked out really well for us because each one of these clusters could go down without affecting the other ones. And for an example of like an image request, it just goes through the proxy, then goes into Nginx from the image cluster, and then directly to S3. So you're not even accessing, in fact, Nginx does that for us. It'll proxy over to S3 for us. So you're not even accessing like PHP or anything like that. So that is super fast. And that's all I've got. Thanks.
I'm going to see if anyone has any questions since we have a few minutes.
Oh, yeah. Yeah, I'll answer questions.
So if we have any questions for Alan, we also have a number of AWS folks in the room, so if there are any AWS questions. Sure.
Yeah. We are, actually, yeah. So we're using auto-scaling across each one of those clusters independently.
Could you repeat the question?
Yeah, the question was, for each one of those clusters, are they auto-scaled independently? So if there's an insurge of uploads, does the upload cluster auto-scale automatically without affecting the other ones? And the answer is yes. So that's kind of, it's not that difficult to set up. You got to do it all from command line, but that's one of the benefits of EC2 and auto-scaling is that each one of those things is totally independent from the other.
Sure.
I believe you mentioned a 2-week cutover from on-prem to AWS
yeah.
for 150 million images. Roughly how much data was that?
It wasn't that much data. Images are really small. Our average image size is like 100 kilobytes. So I would assume that most of the time was like initiating the upload and then actually doing it and then completing it. And we had to do it each one at a time, so it was only, I think it was only about like 10 terabytes.
Over there?
Have you implemented the archival policies? Are you thinking about that?
So, well, now that there's Glacier, that would be a big help. But like I said, we have versioning turned on S3, so if something gets deleted, we can go back and do that. And S3 is so durable itself that we don't really have any additional policies.
Sure.
So you said on the slide you go through, to get your image server at S3, you go through Nginx and HA proxy. Why not just go straight to S3?
So all of our images are like imgur.com / a 5-digit hash. So it's like imgur.com / abcde.jpg. And you have to proxy those to get the correct URL from S3. You can't just have everything like in the root directory, basically. So Nginx merely is just a proxy between S3 and Imgur.
Another question over here?
So the different clusters that you have that are using auto-scaling, are any of those multi-availability zone?
So the question was, are the clusters multi-availability zone? And the answer is everything we do is multi-availability zone. So we literally duplicate all of our servers across, I think it's like zones A and D. Those are just kind of random zones. But yeah, so in the case of, I think EC2 had an outage maybe about a month or two ago. I think availability zone A was affected. And we completely ran totally normal because we had everything on D as well.
I have a follow-up to that, was how do those multi-availability zone clusters interact with RDS, being that that's somewhat single availability zone?
Yes, well, that's not totally true. The question again was, how does multi-availability zone affect like RDS? And so RDS has multi-availability zone instances. And they cost like literally twice as much. But it's worth it when there's an outage. It fails over automatically in a couple minutes. And then now you're just good to go.
Great. Thanks, Alan.
Oh, he had a question.
So approximately how many instances you're running at peak time?
So during peak times, we have almost 70 instances. And that includes all the clusters.
Excellent. Thanks, folks.
Thanks.
A couple of things just to wrap up and review of the session. So what we discussed today, and I'll be available for some follow-up, AWS storage options, so a lot of options to meet your needs, especially in the media use case. Ingestion is obviously job number one, many ways to do that, so think about your use case and what options you want to choose there, be it just over the wire, be it using partner tool sets to speed the ingest, direct connect, import, export. TCO comparisons, we can help. So Alan mentioned that our sales team, biz dev team are available to you if you're struggling or you need to business case justify migration to the cloud and you're looking at TCO comparisons, please call us. We do these all the time, so we can certainly help. And I want to thank Alan for coming out here and speaking to everyone here. And I want to thank all of you for coming out for this session. Oh, this one. In terms of related content, there are breakout sessions in terms of scaling media processing with AWS. Also today at 1 o'clock, at 2 o'clock, Netflix transcoding transformation. It's always great to see how they're doing things because they're so dynamic and they've been with us for quite a while. And of course, addressing security in the media workflow is another session you might want to check out. There are also additional storage breakout sessions. So S3, reducing cost, saving time, is something you might want to look at. There's a great session going on Thursday called Cloud Storage War Stories, stories from the front lines of some of the biggest battles. So you're going to see about 4 or so of our largest customers. They're going to talk about best practices, very similar to what Alan shared with you today. What challenges, speed bumps did they hit, what friction did they experience, how did they get around it, whether that friction was on their behalf or the learning curve to AWS. You also have a chance to hear from one of the senior VPs of IT for Amazon.com. And he'll be talking about how he recently eliminated all tapes in his environment using Oracle RMAN direct to S3 and the cost savings, et cetera, that he experienced in doing so. And it's important to note that although .com is our parent customer, our parent company, they're also a customer. So we earn their business. So it's really good to hear them talk about things and how they migrate to AWS. So that might be a session you want to check out. Lots of resources on the web. Everything we've talked about here today is available on the web. I'd encourage you, if you've got a few hours to kill, to get on Imgur. It's an awesome site. You can have a lot of fun. You'll find me later at the 1 p.m. Understanding AWS storage options, where we're going to go over not only the options that we talked today, but we'll talk a little bit more about the storage related to RDS and DynamoDB. And then, please, we encourage you to fill out the feedback forms so we can improve ourselves for next year. So thank you, everyone. Yeah, thank you.